Having derived two different ways of illustrating profit-maximizing choices by price-taking producers, we can now ask what happens to those profit-maximizing choices, what happens to observable behavior as underlying economic conditions change. In this graph, we'll ask what happens as the wage changes. We begin with the profit-maximizing production plan from graph 11.5, where we assume that the wage is $20 per hour, the output price is $5 per unit, and the production frontier is the one that we first introduced in panel B of graph 11.1. If the wage falls from 20 to 10, that means that the slopes of all the isoprofit lines will become shallower. That further means that the highest possible attainable isoprofit line that still keeps us within the producer choice set will be tangent at a point that lies to the right of point A. Here we have a new tangency at production plan B along the shallower portion of the production frontier. At that new tangency, the production plan tells us to hire more workers and produce more output. We also have a higher intercept for the isoprofit line that's tangent at B. And since price hasn't changed, that means profit has increased. All this should make sense. If the wage falls, we hire more workers, we produce more, and we make more profit. We can show the same thing in our marginal revenue product of labor graph, where at a wage of 20, we're optimally choosing 78 labor hours at the point A prime, which corresponds to the initial production plan A. A change in the wage doesn't change the marginal revenue product of labor, because the marginal revenue product is simply equal to the marginal product times price. As the wage falls from 20 to 10, we therefore simply move to the lower wage and read the new optimal level of labor off of point B prime, which corresponds to the production plan B in the upper part of the graph. We now lose money only on the first 10 labor hours that we hire, and then make money on the next 80, giving us a relatively large positive green area and a relatively small negative magenta area. Our overall profit from operating at point B prime is then the green minus the magenta area. We can tell how big that is by going back to the top graph and checking the intercept of the magenta isoprofit line that's tangent at the production plan B. That intercept is 209. The price P is 5. So our equation on the vertical intercept is profit divided by 5 equals 209. Multiplying both sides by 5, we get that the profit has to be equal to 209 times 5, which is 1,045. Thus, the green area minus the magenta area is equal to $1,045. In panel B, we'll add to panel A by considering an increase in the wage to $30 per hour. This will imply that the isoprofit lines now become steeper, which further implies that the tangency with the production frontier will now happen to the left of point A on the steeper portion of the production frontier. We illustrate this here with a new green isoprofit line that has a slope of 6, the wage of 30 divided by the price of 5, and is tangent at production plan C. Despite occurring at a tangency, production plan C is not, however, the optimal or profit-maximizing production plan now, because the producer can shift to a higher isoprofit line, in particular the dashed green isoprofit line that intersects at the origin of the production plan D. At that production plan, the producer uses no labor to produce no output and therefore makes zero profit. Zero profit is better than negative profit, and at production plan C, we're making a negative profit because the isoprofit line has a negative intercept. Thus, the producer is better off producing at a corner solution, the solution where he chooses no labor to produce no output. We can come to similar conclusions in the lower graph, where we illustrate again the marginal revenue product of labor that's unaffected by a change in the wage. As the wage goes to 30, we move to 30 on the vertical axis and read off the optimal number of workers to hire if we're going to hire workers, which occurs at C prime, which in turn corresponds to the production plan C in the upper part of the graph. Operating at C prime, however, implies losing money on the first 42 worker hours that we hire and making relatively little on the next 17. This in turn results in a relatively small positive green area and a relatively large negative magenta area, with profit as a result being negative. We can see just how negative by going back to the top panel. The intercept of the green isoprofit line that's tangent at production plan C is minus 100. That intercept is equal to profit divided by price, and price is equal to 5. Multiplying by 5, we therefore get that profit is equal to minus 500 at the production plan C, which implies that the shaded green area minus the shaded magenta area in the lower part of the graph is equal to minus $500. We then have two ways of showing how producer behavior changes as the wage changes. We can do so in our top graphs using the production frontier and isoprofit lines, and checking to see how the tangency of the highest possible isoprofit line is affected by the change in the wage. Or we can do it in the lower graphs using the marginal revenue product of labor curve and moving the wage on the vertical axis to see how that changes our quantity of labor demanded. The only thing we have to be careful of is to make sure that whatever production plan we choose, it's a production plan that results in at least zero profit. If it results in negative profit, the producer is better off not producing at all, which is represented by the production plan that lies at the origin of our top graphs.